this afternoon's presentation, we're looking at some of the examples that we've helped companies realize through digital twins, and how we can use what we have now to move forward into the future. So for those of you that don't know, Innovise is a software solution provider. We provide solutions that cover the full built water cycle, so from clouds to sea, and have many solutions in this space, with a focus on hydraulic modelling, asset management, and operational analytics. Last year, we were acquired by Autodesk, and so as we move forward through this presentation, we'll be able to see the 35 plus years that we have as Innovise, working in the water sector with customers globally, how we've been able to use what Autodesk have, and to bring the two together for moving forward into the space of BIM and digital twins. So to start with, what we mean by a digital twin. So for us, what that means is not just bringing information together, it's actually getting decisions and outcomes out of that information. We don't just want to bring data into one place, and while that definitely has a use and is part of the foundation for a digital twin, we don't just want to develop solutions where there is a replica. We need to be able to do something actionable with that. We're not just replicating an asset, a process, a system just for people to look at. There needs to be decisions that can be made from that intelligence information, and so that you're getting better outcomes for a whole host of people, whether that be your customers, staff, but also as we move into more of a climate issue, how that impacts the environment, and the strains that we have on drought, as well as flooding. So as we move through, that's kind of the core focus of what Innovise think that is. So to start with, one of the more basic ways that people might understand a digital twin perhaps, is looking at hydraulic modelling. Hydraulic modelling has been a tool that has been around for many years, and whether that be on a waste or a clean water distribution, it's there to represent your full network, all of the assets within your network, and the interactions that they have with other outside factors. And that is a representation of a system, a process, and an asset. And from that, we are able to make actionable decisions. Some people think that digital twin is always up to date and real time, but having this at the core really means that people can be saving a lot of money on CapEx and OpEx, ensuring that they are designing the network and understand the network as it is now, and then that design and optimization for the future growth of the system, helping with planned maintenance and other activities. And not only is it just an understanding of the network, it can really help inform your investment and the risk and resilience that your networks and assets have, so that you can have an outcome of making sure that you're prioritizing your expenditure for your customers and for the environment. So one of those examples is looking at a utility in the UK. So they are a clean water only provider. They have a full hydraulic model of their full network, an all mains model, with all assets modelled, and have been a customer for many years. And what we have in the UK are asset management cycles, where we have to build business plans for how we're going to spend money and the benefits that that brings to customers and the environment. And so one of the studies that they did was using that model to assess and have an understanding of the critical mains within their network. So this isn't just looking directly downstream of this pipe. There is 1,000 properties, and associating that number. This is looking at downstream. There is 1,000 properties that go without water, but because of this main being out of supply, it also reduces pressure for another 1,000 customers, and that there is critical infrastructure downstream, that there is a hospital, a school, a prison, for example. And so all this information and this added asset information can really help build up the criticality of those assets, either to help you understand where you should have investment to ensure that if that pipe was to burst, for example, how many people would be affected and what would need to be done to make sure that that didn't happen, that we are continually supplying people with safe water, as well as making sure that that investment is going in the right place, that we are not just replacing the biggest mains, the oldest mains, but that we are looking at networks holistically and of the full area that we serve. So this analysis was done, and the graphic on the right we can see there is one of the outputs showing their critical mains, and then they built together design programs for different ways that they were going to deal with that, perhaps laying a parallel main, different valve configurations, etc. And then as we move into what more people think perhaps of a digital twin, looking at the operational management in more real time of the network. So a hydraulic model can give you a representation of an average day, and help you do that planning that we just looked at and prioritize that investment. But as we move forward, we want to be making actionable decisions in real time, and those can often have a bigger impact on people and the environment. So we have the ability with our solutions to bring the live data into one platform to get a representation of your network now. So having that hydraulic model at its core, we can bring in live data to update the model to its latest conditions, what level are reservoirs, what's the level in a river, various information, to be able to give you that representation of the network now. And then more importantly, because it has the hydraulic engine, we can see based on that what will be happening in your network in the next 24, 48 hours using things like demand forecasting and weather forecasting. So it means that we're able to see issues potentially before they happen. And we're able to see that in a platform where everyone can see that information and decisions can be made before going out into the field. So there's a range of ways that people have used this. So from a water distribution, a clean water point of view, some of the information that might be brought in. So we have the hydraulic model as the core basis for the understanding of how water flows through the network, where it flows. And then we have this connection to SCADA, live data, telemetry, that updates boundary and initial conditions of asset statuses, which pumps are on, what valves are open, and any other asset information that you have, together with the demand forecasts to be able to give you that prediction into the future, which is really the most valuable insights and where we can get the most tangible outcomes from such a solution. It's really interesting to be able to bring information together and see that, for what's happening now. But if we're just looking at what's happening now, it's already happened, and it's too late. SCADA systems get threshold alerts, and those alerts have already happened. The information you're getting is in the past, and so we want to try and change that and to give foresight into either incidents or ways that you can manage things better. So some of the things that people can look at are identifying where you might be having areas that are going out of or reducing in pressure, or areas that are increasing in flow, and there may be a burst, for example. And we can look at this from a hydraulic point of view as well as a water quality point of view. So if there is an incident, we can replicate that incident. We can simply burst a pipe, shut down a pumping station, look at a water quality contaminant and see what the effects of that are in real time with the conditions that the network is now, on people and the network and assets. So we can see how quickly a reservoir will drain because of the current demand within the system. There will be an increase in temperature in the next 3 days, and this will increase demand. Does that mean that we need to turn on another pump? We can really have foresight into what we need to do and how we need to operate and manage the networks much more proactively. So one of the user stories from this comes from Australia. They use this solution on their clean water network. They need the ability to transfer water everywhere. They need a very resilient network, as well as looking at reducing energy consumption. Australia is very large and they don't want to be pumping water for no reason. So having that foresight of demand, potential changes and weather can really help them change that and reduce their consumption, as well as just having an awareness. At the moment, every day, how much are we spending on electricity? And so this solution can give them that information as well as something to action. So they use the solution to look forward a week to be able to reduce that risk. They're one of the companies that use it as well for water quality events. So if you were to have an issue or somebody complaining of taste or odor or different colored water, that they can use it to see why that might be in a more of a live environment. And the same kind of solution really applies on the wastewater side, on the collection side. So here there are many more external factors which can impact a collection sewer system, and really a lot of what we're looking at here is more flood incident management. For a clean water perspective, we may be looking at drought as a big issue and being able to forecast that in advance and how to deal with that. Here we're looking at the extreme of flooding, and have a range of those input information to update the model to what is happening now, what are the current river levels, tidal tides, forecast data. So what is now, and again, then what is forecast for the next few days or week, to be able to say, oh, in 3 days there is going to be a massive storm. What do we need to do about that? If we do nothing, this area will flood. If we open this sluice gate, if we do XYZ, then that will have an impact, and you can see that within the solution before it happens, to be able to give you the credibility of the actions that you're going to take, and that everyone can understand why those decisions have been made. So one of the solutions, one of the customers that uses this is Thames Water and Thames Tideway in the UK. They are building a 25-kilometre super sewer in the City of London, and we're talking 3-4 meter high changes in flow through these tunnels. You can kind of see from the picture, and what the solution is able to do is see that there is a storm forecast, and ensures that the workers that are constructing the tunnel and that are cleaning the tunnel, especially some of the sluice gates within the tunnel, workers are in the tunnels basically, and that isn't safe. When there is large rainfall, this is taking that rainfall from London and from the urban area, and so there are live data points throughout the network which connect to the system, and this enables us to be able to send alerts to people. If you can see my mouse on the left hand side, this is an alert that would be sent to an operator to tell them at what time there will be different flows within different parts of the network, and so those can be actioned upon and people can get out. So it gives people enough time for them to safely get out, and this is all monitored through their control room within central London, so they can see the operation of the network, of the tunnel, and the rainfall coming in, and then be able to ensure that there is safety for the construction and health and safety of the workers. So really there is, when we're looking at this, it's not just standard normal urban flooding. It was used in a case with Scottish Canals, who had an area who needed to increase housing, and they had a large a history of surface water flooding in the city of Glasgow, and so they needed to be able to drain this area well, so that they could build upon it, and so with the remote sensoring in the canal and the rainfall forecasts, the ICM Live, the solution, lowers the canal level, and the sluice gates from the land where there was flooding drain the land into the canal, allowing the land to be drained so that it could be built on, but also has gone away from hard infrastructure. We're using a canal that was already there, that can be operated and can be managed and be used as a tool for storage of rainwater, to allow the canal to still be used by boats and people, but also means that it's been used as a vehicle to help the land be drained as well. And so this solution was picked up by the BBC, and I was part of a short video about the solution, how it's transformed Glasgow, how as a result of the project the area was cleaned up, that there has been volunteers and other works done around the area. People have took back ownership of the canal, and it has meant that there has been able to have the building and construction that is really needed for the housing population. So all understanding the full catchment to be able to operate it efficiently. So if you would like to watch the video, it's called Reflecting Transformation, and it's on the BBC Storyworks website, so please do have a look at that. So by having these solutions that can bring various outcomes, by having them in a solution that's accessible to all, that people can understand things in a geographic view, you can see rainfall coming over your area, it means that operators feel much more ownership of and understanding of the information they are seeing. Not only is it just using the live data and the SCADA that you already have, but it's putting that not just in alerts and numbers on a screen in a SCADA system, but by having it visually and geographically, connecting it to Google Maps, it's able to be much more tangible for people to make the right decisions, whether that be for people to understand where assets are, but also be able for you to try those scenarios, to see how the effects of a pipe burst, some flooding, a sluice gate not opening, a pump shutdown, how that affects people, and how you as an organization can deal with that in the best way. And so as we move forward with this, we are, or more and more people, want to learn about how we can evolve the information and the outcomes that we see from various types of digital twins with the asset management information that we're seeing. So how can we inform asset management decisions and investment in different assets and parts of the network with the design and with the operation of the network? So being able to bring that information into an even more intelligent digital transformation, for one to be able to inform the other, and for them to be connected. And so as people look to do more of these types of works, they maybe want that criticality that we talked about at the start, the criticality of each main. They want to know that in an operational environment in case they have an incident, and they can quickly say this pipe affects 1,000 people. So there can really be that transfer of information that can be useful to the whole organization. And so as part of that, as we move more into the cloud, we can bring lots of these things together in a more streamlined fashion that was probably harder before. There would be a modeling team that would be siloed from asset management, that would be siloed from operations. And hopefully as we move forward, we're able to do much more analytics in a much more holistic, full environment. And what this means, therefore, as we move to some of these cloud solutions, that we are able to use the benefits of multiple parts of these platforms that we have. What we haven't spoken about today is treatment plants, for example. How does optimizing the pumps of a treatment plant, how does that feed into your network operations, for that to be for that to ensure that it still supplies people water, but also that is optimal. So it's linking different parts of the network. If you're having a flood, where is that, and is that likely to affect some of the planning and operations that you're doing on a clean water supply point of view? So bringing some of the outcomes that we have from various parts of the organization into one platform to be able to make quicker and better decisions. And so as Innovise, as we move out, as we move forward with the solutions that we have, that we continue to develop, that we continue to use and continue to be used throughout the world for a whole range of reasons that we've seen, we then also work with Autodesk to try and figure out the way that we can use water infrastructure through the whole environment, but ultimately, as I just said, really bringing that information together to be able to improve all of the capabilities that we have, and that really be actionable for you. So that is the end of my presentation. Thank you very much. If you have any questions or you'd like to say anything else, or you can't remember the link to the video, then yeah, please do get in touch.